4s! I'm glad you decided to join me for some math today. So get your booklet and a pencil and we're going to work through this step by step. If you have any questions, hopefully this video helps you and makes you sure that you're on the right track. So let's get started. Okay, so the first question today for grade 4 math is, what is a vertex? Now, I think we have covered this in class a little bit, but the vertex is just a fancy word for a corner. And the math definition is it's where two line segments meet. So looking here, there's where my two line segments meet. That would be a vertex. Oh, and now I have more line segments meeting. So I have 3 vertexes on this triangle. Okay, number 2, how many sides does a parallelogram have? So remember when we were in class, I said a parallelogram is kind of like a rectangle that's been pushed on its side. So it has 1, 2, 3, 4 sides. And if you want to get fancy, it also has 1, 2, 3, 4 vertices, vertices. All right. Number 3, draw the lines of symmetry for this square. So symmetry is anywhere that I would fold the square in half and it would be the same on both sides. So if I folded it this way, it'd be the same on both sides. If I folded it this way, sorry for my messy writing, it'd be the same on both sides. We could go straight down the middle. We could go straight across. Okay, so a line of symmetry means that both sides are equal. Okay, number 4, what 3D figure does this object look like? So if you imagine that you're playing pool, and this is an 8-ball, it looks like a sphere. A sphere. Or you could think of the globe of the world, that's also a sphere. So it's like a 3D circle. Okay, draw the reflection of this shape. So here's our line of reflection. And then on the other side, we want to make sure that it's a reflection, so it's facing. So I've got a line this way, I draw it this way, and then it comes up like this. And you don't have to get a ruler and make this fancy. You can just draw it. So this is a reflection of this. Imagine that this is a mirror. So it's the same but opposite of this shape here. All right, so we're going to move on to our fact of the week, our problem solving. So the fact of the week today is most spiders will live for about a year and eat about 2,000 insects in their life. So we are going to read through the fact and the question. So it says, most spiders will live for about a year and eat 2,000 insects in their life. So that's important information for our problem solving today. And so Wednesday, based on this week's fact, Kylie says that a spider will eat about 120 insects per month in its lifetime. But Jarrett says that this should be more like 5 insects per day. Are either of their answers right? So some facts that we need to know, some information. We need to know that there's 12 months in a year. So to figure out Kylie's fact, we have 2,000 insects and there's 12 months in a year. All right, for the problem solving, they're using the word about. So if you look, the spider will live for about a year and eat 2,000 insects in its life. And then Kylie says that it'll be about 120 insects. Since we have that word about, we know that this is an estimate. So all we have to do is kind of check it out, check out our math. So we're going to go through here and we're going to check what they're saying. We don't have to figure out the exact, but we're going to check what it's saying and see if that is something that's reasonable. Okay, so we're going to go through and see if it's reasonable. So the first fact that we can check is Kylie's fact, and it'd be quite easy to check that. Looking here, okay, so 12 months, 120 per month times 12 months. Well, I know that 12 times 12 is 144. And then 120, because it's 10, we just add a 0. So I know it's about this much. If we use Kylie's math, 120 times 12 is about 1,440. Because I just do 12 times 12, and then because it's 120 with the 10, it's groups of 10, I just add a 0. So I think that Kylie's estimate is a little bit low, because she's she's saying if we used her math, it would be about 1,440. So Kylie's is definitely low because Kylie's estimate is low. It is too low. All right, but let's check out Jarrett's estimate. So I'm just going to make space on my paper here. Jarrett's estimate, Jarrett says that it should be more like 5 insects per day. So Jarrett is doing it a little bit differently. He's doing, so 2,000 insects per year. Okay, and that is 365 days. So we're going to go 365 times 5. And you think, oh my goodness, Mrs. Oakes, I don't know how to do that. But you do, because we've been practicing this. So stack your numbers, 365 times 5. I'm going to use partial sums for this. 5 times 5, or sorry, partial products is 25. 5 times 60, well, 5 times 6 is 30. So I add a 0 because it's on 60. Okay, and then 5 times 300. Well, 5 times 3 is 15, and because it's 100, I just add 2 zeros. So 1,500. Now, I'm going to add these together. So I'm going a little bit out of the box here, but that's okay. So I'm going to put my total down here. 5 plus 0 is 5. 2 plus 0 is 2. 3 plus 5, so 3 plus 2 is 7. 1 more is 8. And 1,000. So Jarrett is a little closer to the actual because he's 1,825 or 1,800 is pretty close to 2,000. So I would say that Jarrett is pretty close. Jarrett's estimate is more reasonable. Jarrett's estimate is more reasonable. Now, do either of these humans have it completely right? No, neither of them got it exactly right, but if I had to pick a person who was working closer to the right answer, it would be Jarrett. Okay, now we're going to go on to the next question. Okay, so for this one, it's asking you to color the circle according to the directions. So color 3 parts red, color 4 parts blue, and color 1 part green. Now, if you're like me, and you might not have all the colors at home, I'm going to pick close. So I'm just going to underline, this red is going to be pink, because that's as close as I have. And I'm going to have 3 pink parts. So again, I don't have to color it perfectly, but 1, 2, 3. Okay, my next one, blue. Now I do have a blue pen here, so I'm going to grab my blue pen, get this blue pen. Okay, and so I go blue. I have 4 parts that are blue. I'm going to color 1, 2, 3, 4. And then 1 part is green. I have my green pen here, so I'm going to color green. Now, to make a fraction, you might think, we haven't done this yet, but you've worked on fractions in grade 3, and you've worked on fractions in grade 2, so this is nothing new. Let's go through and remember the rules of fractions. So to make a fraction, we figure out first how many pieces are all together. So remember, for a fraction, they have to be equal pieces. I'm going to count the pieces. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 parts. So all of these are going to be out of 8. So for red, I count 1, 2, 3 out of 8. 3 parts out of all 8 are shaded red. Okay, which fraction of the circle is blue? So let's count. 1, 2, 3, 4 parts out of 8. Which fraction is green? Oh, just 1 part out of 8. 1 out of 8. So we have 3/8, 4/8, and 1/8. So just imagine it's like I would say a spelling test. Your number that is out of is going to go on the bottom, and the number that are shaded or the number that are correct go on the top. So it's just like when you write your spelling test scores out. So 3/8, 4/8, and 1/8. Now some of you are going to be saying, but Mrs. Oakes, if you look at the blue, you've colored in half. And if you really wanted to get fancy, yes, you've also colored in half in blue. Okay, because it's the same, it means the same thing. All right, I'm going to move on to the next page. So for this page today, this is from our multiplication station for today, and we're going to be working on orders doesn't matter. So this array shows 4 groups of 3. This can be written as 4 times 3, but it also shows 3 times 4. We can write that as 3 times 4. No matter which way you multiply the factors, the product will still be the same. So in grade 3, when we were drawing a lot of arrays, you would have noticed that it doesn't matter which way you put the dots, the number of dots doesn't change. So it says write 2 different multiplication equations for each array. So looking at my array, this one I know I have 2 groups of 1, 2, 3, 4, 5, 6, 7. Okay, 2 groups of 7 is 14. But I could also have, so look this way, it's 2 groups of 7. And I'm just going to change color so you can really see here. But I also have groups of 2. So if you look here, I also have groups of 2. So I also have 7 groups of 2 are 14. Okay, now looking here, this is equations for each array. We have 1, 2, 3, 4. So we'll start with groups of 4. 1 group of 4, 2 groups of 4, 3 groups of 4, 4 groups of 4, and 5 groups of 4. So I have 5 groups of 4, which is 5 times 4 is 20. But I also have, I'm going to switch colors here so that you can really see it, groups of 5. 1, 2, 3, 4, 5. So if I group them this way, I have groups of 5. 1, 2, 3, 4 groups of 5. 4 groups of 5 is also 20. So I've written it 2 different ways, but the product is the same. Okay, let's go on to this one here. So we're asking, they're asking me to make 2 arrays. So I see groups of 3 first. I'm going to start with my groups of 3. 1 group of 3, 2 groups of 3, 4 groups of, 1, 2, 3 groups of 3, 4 groups of 3, and 5 groups of 3. 1, 2, 3, 4, 5. So I have 5 groups of 3. I'm going to switch colors and we're going to group the array the other way. I have 1, 2, 3. 3 groups of 5. So 5 times 3 is 15. And I group it differently, but it didn't change the number. 3 times 5 is 15. Now it's asking you for the next one to draw draw arrays to match the equations. Fill in the product for each equation. So let's do this together. 5 times 4. Remember, with arrays, we want them to be in neat lines. We want the lines to match up. You're not just drawing a bunch of dots all over the paper. So 5 times 4, I'm going to have 5 rows of 4, 5 groups of 4. So 1, 2, 3, 4. That's 1. 2 groups. 3 groups. 4 groups. 5 groups. 1, 2, 3, 4, 5 groups of 4. And they're going to be 20. Now I could also, it's also 4 groups of 5 because I've got 5s. 1, 2, 3, 4 groups of 5. Oh, sorry, I wasn't entirely on my paper here. All right, on to the next part. 7 times 3. So that means I'm going to have 7 groups of 3. So 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3, 6 groups of 3, 7 groups of 3. 1, 2, 3, 4, 5, 6, 7. And that 7 times 3 is 21. 3 times 7, again, here's a group of 7. 1, 2, 3 groups of 7 is also 21. Okay, on to the next one. 2 times 6, so 2 groups of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's the same as 6 times 2, because look, group of 2, 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 group of 2. I have 1, 2, 3, 4, 5, 6 groups of 2, or 2 groups of 6. Doesn't matter which way you group them, your arrays stay the same. Okay, so the next one says use each set of numbers to write 2 different equations. So, okay, look at this. They're making this pretty easy for you. So 4 times 8 equals 32. 8 times 4, oopsie, equals 32. 7 times 5 equals 35. 5 times 7 equals 35. Okay, 11 times 10 equals 110. 10 times 11 equals 110. So you're seeing here that it doesn't matter which order you do it, the answers, the product remains the same. 4 times 11 equals 44. 11 times 4 equals 44. Okay, 9 times 8 is 72. 8 times 9 is 72. All right, so that's our math for today. If you wanted a little extra, you could go on to SumDog today and try to challenge some friends. I challenge you to get onto SumDog today and check out the multiplication challenge. So everyone in the class is trying to get 50 correct answers by the end of the week and make it onto the leaderboard for our multiplication challenge. So it doesn't matter if you get them wrong, right? If you get a couple wrong, that doesn't take away from your total. You just keep working on those 50 right answers in your games. And I will see you tomorrow for more math. Helped you if you were stuck, or let you check your work if you knew what you were doing. If you have any questions, send me a message and I can help you on Class Dojo. And make sure you check back tomorrow for more math. Have a great day.